In this presentation, we will continue with our introduction to the programming language R, and we will be looking at vectors this time. So open Rstudio and then start a new script by going to File and choosing Rscript. It's a good idea to save and name the file before we get too far, so let's right away go to File, Save, and then when the dialog box opens up, we will find the location where we want to save the R program, and then give it a name. I've given it the name vectors.r. Again, the extension .r will help your computer know that it's an R program, and your computer might be trained to then open R programs with Rstudio, and we'll make that interaction easier. Let's review some things about Rstudio before delving into the specifics of this program. So there's a script area in the upper left where we're going to write our code. And then below that in the lower left, there is a console where we will see some of the output once our code is executed. There may be some stuff in there in the beginning, and if you want to clear that out, you can type Control-L on the key as a keyboard shortcut. In the upper right, there is a region known as the environment, which is also affected by the code you execute. And it may have some results from some previous code that you've executed. And if you want to clear that out, there's a little broom icon which you can use to sweep the region clean of old results. In the script region, if a line begins with a pound sign or a hashtag, then it is a comment, and then it is meant for a human reader and does not affect the execution of your program. The tab area, which has the name of the script that's at the top of the script region, in the example shown here is red, and that is an indication that the script has been edited but not saved. And if you wanted to save it, then you would hit the little floppy disk icon is shown in sort of light blue. Then if you want to actually execute code, and the line of code, line 8, has been executed in this program because I can see its effect down there in the console. If you want to run the line of code, then you highlight the line of code and can click the button Run at the top of the script area. Okay, now let's talk about this particular program. In a previous program, we introduced the concept of variables, and one of our examples was from chemistry, and we had a bunch of variables that were the atomic weight of carbon and the atomic weight of hydrogen and so on. But when you have a collection of related variables that sort of have the same role, and just, one for carbon, one for hydrogen, so they are related like that, then you can make them form what we call a vector or an array in programming. And so here's a line of code which we will examine in more detail in the next slide, but this is the code to sort of create, instead of 4 individual variables, a vector of variables. So let's examine line 8, the only line of executable code so far. We have atomic underscore weight, then we have one of those arrows, then we have C open parenthesis, 4 numbers separated by 3 commas, and then a close of the parenthesis. So parentheses usually indicate a function in programming, and the C is what R calls the concatenate function. So one thing is we're doing atomic stuff, but C, the little c here has nothing to do with carbon, first of all. Now you recall from our previous example when we were doing simpler variables, that little arrow, the less than and the dash, are just how we assign something. So we're going to give something a value, and we could just as easily have used the other approach where we use, say, an equal sign. What's over on the left, atomic underscore weight, is just the name of our variable. And so it usually starts with letters, and it can have underscores and numbers. And dots are also allowed, but dots are a little sort of beyond our scope here. And then compared to what we previously did, where we assigned sort of a single numerical value to a variable, which might change, but at a given time, the variable had one value. Now we are assigning a collection, a set of 4 values to this name atomic weight. So atomic weight is now standing in for 4 different things. This is the idea of array or vector. My next line of executable code, I'm going to assign another vector. I'm going to standing for caffeine subscripts, and I'm going to assign it the values of 8, 10, 4, and 2. So the molecule of caffeine has 8 carbons and 10 hydrogens and 4 nitrogens and 2 oxygens. So I'm choosing those, I'm calling them subscripts here, those values for caffeine. So the previous vector was generic to just atoms, and now I'm doing a specific molecule telling me how much of each of those atoms I have in the molecule. So it's just another vector in terms of programming. And I want to point out that I can use this same concept even if I'm doing something that doesn't have, say, carbon and nitrogen. So water doesn't have carbon, only has hydrogen and oxygen. And so then I can just put zeros in there. So water would be 0, 2, 0, 1. No carbons, 2 hydrogens, no nitrogens, 1 oxygen. So I don't have to sort of start all over again if I wanted to do water. So in my next line of executable code, I am taking my vector for the caffeine subscripts and I'm multiplying it by my vector for the atomic weights, and then I'm assigning that result, and it's going to be another vector, to what I'm calling caffeine atomic weights. So when you multiply 2 vectors, you take the first number of vector 1 and multiply it by the first number of vector 2, and then you take the second number of vector 1 and you multiply it by the second number of vector 2, and that creates for you a new vector. So when I multiplied the caffeine subscripts by the atomic weights, I multiplied 8 by 12, and then next I multiplied 10 by 1.008, then I multiplied, that was the hydrogen, then for the nitrogen I multiplied 4 by 14.007, and finally for the oxygens I multiplied 2 by 15.999. And then I have this new vector as a result. And then I have, on line 22, I just have the name of that vector again, caffeine atomic weight, caf underscore at underscore WT, and that just sort of displays the results. So the first one actually did the multiplying and created and assigned the value, and then the second one, when I just give the name, it just sort of spits it out down in the console so I can see it. Just a note about terminology. I tend to use the following terms somewhat interchangeably. I'll talk about components of a vector, or items in a list, or elements of an array. Okay, now let's look at line 27 in the code. So I have caffeine underscore molecule underscore weight equals sum, parentheses, caffeine atomic weight, close parenthesis. So sum is a function, and the argument of the function, what's inside the parentheses, is known as the argument. The argument is a vector. And so I'm going to sum a vector. And what that means is I'm going to sum the components, or I might say I'm going to sum the items, or I'm going to sum the elements. So again, I'm going to use these terms rather interchangeably. So I'm going to sum all those elements of the array that I just got previously, and then again that line of just caffeine mole weight at the bottom on 28 is just going to spit out the answer. So when I sum them, the caffeine atomic weight is a vector. It's sort of 4 things. It's an array, it's a list, it's a vector. And then, but when I perform the sum function, I'm just going to get one thing out of it. If we are distinguishing one thing versus a set of things, we will often use the term scalar. So this is, we've moved from a vector to a scalar here. So in the next line of executable code, 34, I have caffeine percent weight, that's something new, equals caffeine atomic weight divided by caffeine molecular weight times 100. The caffeine atomic weight was a vector, and the caffeine molecular weight was a scalar. And so the vector is a set of 4 things, whereas the scalar is just one thing. And then I multiply by 100 and assign it to this new thing, caffeine percent weight. When we divide a vector by a single quantity, so a vector is a set of quantities, so if we're dividing the set of quantities, a vector, by a single quantity, a scalar, then what we do is we take each part of the vector, each component of the vector, and divide it by that number. And it would be the same if we were multiplying. If we multiplied by a scalar, then we would go through and multiply each term by that scalar quantity. Okay, so we are taking the atomic weights, so how much of caffeine is carbon, and then dividing by the sum, the caffeine molecular weight was the sum, and multiplying by 100. So really what we're calculating here is a percentage. What percentage of caffeine is carbon? What percentage of it is hydrogen, and then nitrogen, and then oxygen? So we see what we've calculated here is that caffeine was about 49.48% carbon by weight, and so on. So when learning to program in R, it's important to practice, to make mistakes, to debug and find those mistakes. And so let's do an example of this little program involving vectors. So take my program that figures out the percentages by weight of caffeine, and I want you to do it for fructose, then sucrose, then lysine, and submit your R script.